Now let us discuss different types of sets. The very first is empty set. So it is a set having no element. It is usually denoted like this, curly braces without any element, or simply by phi. The next is singleton set. It is a set having only single element. For example, this is a set having only single element, namely A. We have a notion of universal set. Now the universal set cannot be defined universally. It depends on which structure we are working with. For example, if we are working with numbers, then the universal set can be considered as real numbers. If we are playing with students, then all students of the college can be considered as a universal set. So the definition cannot be defined universally. But what will be the universal set? Whatever structure in which we are working, उसमें से सबसे बड़ा set possible can be considered as a universal. There is a nice pictorial representation of sets called as Venn diagram. So in Venn diagram, there are only two rules. The very first rule is universal set is represented in the form of rectangle and all other sets are represented in the form of oval. For example, in this Venn diagram represents that there is a universal set. There are two sets, namely A and B. Now as the oval A sits inside B, that means A is a subset of B. Now let us discuss the algebra of sets. The very first is union of two sets. So let A and B be any two sets. Then the union of A and B is denoted in this way, AUB, and it is defined as it is collection of all X in universal set such that X is either in A or in B or in both. For example, if I have a set A having elements 1, 2, 3, 4, a set B having elements 3, 4, 5, 6, then A union B would be a set having elements 1, 2, 3, 4, 5, 6. We can visualize this union in the following. Next is intersection of two sets. It is denoted in this way, A cap B, and it is defined as collection of all X in U universal set such that X is in A and X is in B. So we collect all X which are there in both. For example, if I have set A as 1, 2, 3, 4, B as 3, 4, 5, 6, then A intersection B is only 3, 4 because 3 and 4 are the only elements which are there in both. So the intersection of two sets can be visualized in the following way. Next is difference of two sets. It is denoted like this, A minus B. It is collection of all X in U such that X is in A and X is not in B. That means we are removing a part of B from A. हम A में से B के सारे elements को निकाल रहे हैं. For example, if I have a set A as 1, 2, 3, 4 and B as 3, 4, 5, 6, then A minus B would be removing B ka part from A. So here I can see 3 and 4 are the members of B which are in A. So we'll remove it. So what would be A minus B in this case? It would be 1, 2. That's it. The difference can be visualized in the following way. We are removing B from A. Similarly, we can define B minus A, wherein we will remove A ka part from B. So for the same example, B minus A would be 5 and 6. Next algebra is symmetric difference. So the symmetric difference of two sets is denoted in this way, A del B, and it is defined as union of A minus B and B minus A. For example, if A is 1, 2, 3, 4, B is 3, 4, 5, 6, then we have seen that A minus B is 1, 2, B minus A is 5, 6. So union of these two would be 1, 2, 5, 6. That is the symmetric difference of A and B. The same can be visualized in the following way. The same can be expressed as A union B and then removing A intersection B from it. So the equivalent definition of symmetric difference of A and B is taking first union of A and B and then removing A intersection B from it. Refer the PDF attached in the description for more problems.